In this lecture video 5, we're going to study rules of differentiation. So there's the previous lecture, we did the first principles where we derived the derivatives formula. Now we're not going to use the derivatives formula to solve, we are applying rules. There's approximately about 10 to 12 rules that you need to know for this AP Calculus, BC and AB course. So let's look at rule number 1, which is called the power rule. So in the power rule, if we have, I will write down the general rule and then we'll do examples. If we have something like ax to the power n, right? And if we're trying to find the derivative, remember the n is on top. If you're trying to find the derivative, say y prime is equal to an. So you multiply the power with the constant, multiply those two out. So it becomes an x to the power n minus 1. That's it. And take away 1 from the power. Right. So remember in first principles, in the previous lecture, we had what we had? We had y equals x squared, okay? And I wrote down y prime is 2x. So let's look at that. So we had y is equal to x squared. What is y prime? Let's apply the rule here now. So if there's nothing in front of x squared, there's a 1 there. You can't say there's nothing. Nothing means like 0. So there is a constant 1. So 2 times 1, right? You're taking 2 times 1 and subtracting 1 from the power. So x to the power 2 minus 1. So now simplify this. You will get 2x. Are we good, guys? Let's look at the next example that we did from in first principles. We had y is equal to x cubed minus 3x, and I think it was 2 plus 2. So if you go back to first principles, in the previous lecture video we were doing the long method, first principles, x cubed minus 3x plus 2. So there's it here, x cubed minus 3x plus 2. If you're trying to find the derivative of this function, we're going to get y prime is equal to, so it's 3 times the 1, there's a 1 here in the front, 3 times 1 is 3, take away 1 from the power, so that's x squared, okay? Then remember, next to the x there's a power 1, and next to 2x this is x to the power 0, so I kind of like added x to the power 0 here, because x to the power 0 is 1, it's not going to change the value of the term. I added power 1 here, it's not going to change the value of the term. The reason why I'm putting x to the power 0, because this is the power rule. Alright, so we got derivative 3x squared minus 3, right? Because 1 times 3 is 3, x to the power 0 plus 0. No use doing that one, because now what's your final answer? Your answer is 3x squared minus 3, okay? So let's see if we had that answer there. 3x squared minus 3. That's what the derivative by using the rule. And that's what we have here. Okay? Are we good, guys?
Yes.
Excellent. Yep. So this is the power. Now let me give you one more, because you need to know rules of exponent. Remember when we have a radical, rules of exponents, rules of exponents and radicals. Radical rules and exponent rules. You must know these things, right? Basic rules, because this example is going to be very long, right? So I'm going to give you a long sum. So what did you learn from this example? That the derivative of a constant is always 0. It's like I'm asking you, what's the slope of this line here? What's the slope of this line? Minus 3. Just write down minus 3. That's it. What's the slope of 2? The slope of a horizontal line is 0. So that's why the derivative of a constant is 0. Okay? Now let's look at rules of exponents. So if you have x to the power nth root of x to the power m, it becomes x to the power m over n. Okay? What if you have 1 over 1 over x to the power n, what will this become? Or let's just say 10 over x to the power n, or 10 over x to the power, let's just say constant over x to the power n. That will become constant x to the power negative n. Power rule says you must write it in a straight line form. Okay, so these are two important rules that you need to know. Are we good, guys? So here's an example 1.3. Those are just rules, and there's the example that you need to differentiate. So we have f prime x is equal to f prime x is equal to sorry, not f prime x, f of x is equal to 5x cubed negative 5x cubed plus 10 over x squared minus 3 root x plus 1 over cube root of x plus 20. How are we going to do this? You write it in power rule form first. So negative 5x cubed plus 10 x to the power negative 2, that's negative powers, minus 3 inside over outside, x to the power half, plus 1. You don't write plus 1. You can take, okay, let's change this to plus 10 over. So plus 10 x to the power negative. Why negative? Negative inside over outside. In the denominator is 1/3. So if you take it up, it becomes negative 1/3 plus 20. Now you can differentiate. So you say f prime x is equal to 3 times negative 5. Now you're differentiating. Once you differentiate, then you apply the rule, power rule. Now you're applying the power rule. So 3 times negative 5 is negative 15. Take away 1 from the power, x squared. Minus 2 times 10 is minus 20, x to the power negative 3. Because minus 2 minus 1 is negative 3. Negative 3 times half is negative 3 over 2. X to the power, what's half minus 1? Negative half. 10 times negative third is negative 10 over 3. X to the power negative. Take, it's negative 1/3, negative 1. So that's negative 4 over 3. And the derivative of a constant is 0. So that's your answer. You don't even need to write 0, okay? Are we good, guys? Now,
Yes.
how we can put this in the original form, like what we had it like this. We can put it in the original form. That's negative 15x squared minus 20 over x cubed. The negative half says that must go down and is square root. Minus 10 over 3, and this says must go down and it's a cube root of x to the power 4. Are we good? You must know how to write in different forms. 3 times the cube root of x to the power 4. Negative powers means it's in the denominator. And fractions on the negative power, fractions on the powers mean is a radical. Okay? Now, what are different notations that we can use for derivatives? What are derivative notation? Derivatives notations. And what do they mean? Derivative notation means I already taught you 2 of them, right? So there's 2 more. There's kind of like, let's say, if we have y is equal to x squared, right? We know the derivative. I'm going to do different notations now, each notation, all right? So we got y is equal to x squared becomes y prime is 2x. We did that before. If we have f of x is equal to x squared, f prime x is equal to, okay, let's change the function, right? So just for understanding purposes, let's just say 2x cubed. If we have 2x cubed, so f prime x will become 3 times 2, which is 6x squared. That's your second notation. Third notation, we have y is equal to 5x to the power 6, so, or negative 6. what is dy dx? It's the same thing as saying y prime. What is dy dx? Negative 30 x to the power negative 7, which is negative 30 over x to the power 7. So you have 1, 2, 3 notations so far. What's the fourth and fifth notation? You can also ask the question, what is d dx of 2x minus 3? There's the third notation. When they say d dx, it means there's your y value here. You're finding the derivative of this function. There's your function here. You're finding the derivative with respect to x. Derivative of x with the derivative with respect to x of this function. So the answer is just 2, isn't it? And the last one is dx of let's just say sine x, derivative of sine x. So this dx, you drop the dx after you differentiate. So there's your function here. Okay, what's the derivative with respect to x of sine x, which is
Cosine x.
So these are the 5 notations that you need to know for derivatives. Are we good? So if you see
Mr.
stuff like,
How about if you want f double prime?
we're gonna do that, just chill. I didn't even come to sketching functions and stuff. I'm only doing differentiation rules at the moment. All right, so let's find there's only one rule I did so far, which is the power rule. Let's look at the next rule. Next rule is called the chain rule.
This chain rule caused me problems, wallah.
Let's do it now. Chain
Mister,
rule says
it's n f of x to the power of n minus 1 times f prime of x.
One second. We got y equals a function raised to the power n. Or if you have a constant in the front, no problem. You're going to do the normal thing like the power rule. So what's y prime? C times n f of x
Sir,
to the power n minus 1. Yes.
I know this is like ahead of what we're doing right now, but there's a question which I don't understand.
Yeah. What's the question?
Can I send the question to you?
You can send me the question, but can I answer it at the end of the session, please?
Oh, okay.
Right. You can send me the question at the end of the session. Let's do all these rules first. All right. So we're going to say c times n f of x to the power n minus 1. The only difference with the chain rule is that you have to go and differentiate the inside function. You know the function that you're raising. So you have to differentiate this. So you just say times f prime x. That's your general rule. Let's take an example. We have y equals 2x squared plus 1 to the power 10. Now, you're not going to use binomial expansion and expand this entire thing 10 times because you will end up with 11 terms. All right? You'll end up with too many terms. So the idea of chain rule is when you have powers, right? Higher order powers, you just differentiate using this rule here. So you're going to say y prime is equal to 10. 10 times 1. Does anyone want to try this out?
Wait, mister. So this you do
10 times 1 is 10.
10 of
2x squared plus
2x
1
squared plus 1.
the power
9 to the power of 9 times
the derivative of the inside only.
4x
That's it.
times 4x.
Times 4x, good. Because 2 times 2 is 4, and 4 times 2 times 2 is 4, and take away 1 from the power. That's
Yes.
it. And the derivative of the constant is 0. Did you guys understand this? Any questions, guys?
Wait, so sir, the chain rule is just saying that it's
Same as
y
the power
is
rule.
it's
Same
the
as
same
the
thing as
power
the
rule.
power rule. It's just a function inside of a
You
power.
must differentiate, yeah. You must differentiate
Okay.
these. Yeah,
Mister, can you do the chain rule with the roots?
yeah. 2.2.
Because that's the confusing one.
Right, so if we have the cube root of 5x cubed minus 3x squared plus 1, okay, no problem, we can write this as a power inside over outside. So this entire thing is a function the raised to the power 1. So we're going to rewrite this function as y equals 5x cubed minus 3x squared plus 1 to the power 1/3. Okay? So what's y prime? Y prime is 1/3 times 1 is 1/3. Come on, anyone wants to give it a try?
Mister,
1/3,
this will be,
one
isn't
third.
this just the same thing as f of x
Yeah.
times
Yeah.
1 over 3?
What do you mean f of x times 1 over 3? It's f of x to the power 1 over 3.
Okay, so then we
1
find the
over 3 times,
derivative of the middle function.
not yet. We're going to say 1 over 3 times 1 is 1/3. 5x cubed minus 3x squared plus 1.
Plus
Take
1,
away
and
1,
then you
minus 2/3. And now you find the derivative of the function that
which
you're
is
raising the power to.
15x cubed, x
X
squared
squared
minus
minus
6x.
6x. That's it. All right,
So
guys.
always when we're dealing with chain rule, it's we deal
Differentiate
with
the
the
inside
inner
function.
function first and then the outer function, right?
No, the outer function first and derivative of the inner function last.
Okay.
Right?
Wait, Mister, can't the first part be simplified even more?
Yes, you can. You
We
can take
can,
out the
right? We
three.
do everything
Yeah.
squared or 1 over this function inside of a cube root.
1 second. Come again.
So the first part on the left, 1 over 3 times 5x cubed minus 3x squared plus 1 is the power of negative 2 over 3. We could do 1 over 3
Times
times,
the second part only.
yeah, times the second part only, and then we
Yeah.
also simplify the
Yeah,
first
you're
part
supposed to.
by
No, you can't.
saying
The
yeah, you can.
first part. The first part you can write it in a radical form. No need to do
We can
that.
write it in a, yeah, that way, yeah.
You can write it as like this: cube root of all of the squared.
All of the squared, yes.
No need to do that, right? Because we already know what
Okay.
that means. We can take
Okay.
the 1/3. You're supposed to simplify. Take the 1/3 and multiply into the second bracket, and we can get
Yeah.
an answer. So you got 5x
It's 5x
cubed minus.
squared. Oh, okay, yeah.
Because when you're doing maximization, you're supposed to simplify. I just want you to apply the rule directly without simplification. But since you can see the easy simplification, we will do this. So 1/3 times 15 is 5x squared. And 1/3 times minus 6x, 1/3 of 6 is minus 2, minus 2x. You can also take out an x as a common factor. You're supposed to have it completely factorized as well. Okay? You can take out x as a common factor from here and take it out, right? But it's fine. Second, all right, so this was 2.2. Let's take one with the square root, right? But square root in the denominator, right? So we got 3 over the square root of x squared minus 2. So we're going to rewrite this function as 3 open bracket x squared minus 2. That's the function x squared minus 2. This is raised to the power half, but negative half because it's in the denominator. Now we find y prime, the derivative of this function. 3 times negative half is negative 3 over 2. X squared minus 2 to the power negative 3 over 2. Times the derivative of the inside, which is 2x. Because 2 times 1 is 2 and take away 1 from the power. So now we can see clear cancellations. We can see that the 2 cancels out with that 2. We are left with negative 3x on the numerator, right? All over the cube root, the square root of, no need to put a 2 outside, x squared minus 2 all cubed. Right, so you can, yeah.
There is an example in the calculus book I sent you in the chain rule. It says d of dx of u to the power of minus 1 times du over dx. How do you do that using chain rule?
Oh, we can't do it now because we need to learn more derivative rules. I understand what you're saying.
And
need
can
to
you do
teach
an
you-
example with composite function, please?
Yeah, we're gonna do it. Just wait, just hold on. I'm gonna do everything. So how many rules did we learn so far? We did the power rule, we did the chain rule. Let's move on to the next rule, which is called the product rule. So what is the product rule? Product rule says, okay, if I have y equals f of x times g of x, then the product rule says differentiate the first function, leave the second function, plus differentiate the second function and leave the first function. That's it. Let's take a simple example. If we have y equals 5x minus 1 into 3x minus 3x plus 2, for example. So the product rule says, let me differentiate the first function, 5x minus 1, it is 5. Leave the second function, which is 3x plus 2. Add, differentiate the second function, which is 3, and leave the first, which is 5x minus 1. You're supposed to simplify. 5 times 3x is 15x, 3 times 5x is 15x, so that's 30x. 5 times 2 is 10, 10 minus 3 is plus 7. Are we good, guys? So there's your first function, which is f. There's your second function, which is g. So let me write it here, f and g. This is f and this is g. So moving it down, let me just simplify. Okay, we simplified this. So there's your f prime. There's your f prime function. There's your f prime. There's your g function. I left and I said plus. There's your g prime function. And I left the f function. Okay? You guys understand? Let's move on to the second problem, 3.2.
Mr. Ghazali,
Yeah.
I send the question in the chat.
Okay, I'll look at it at the end of the session. Right, so question 3.2. We have y is equal. Now I'm going to combine the chain rule and the product rule together. So I will do something like this. I will say, all right, so I have same thing, 5x minus 1 to the power 6 and 3x plus 2 to the power 5, for example, right? So what is y prime? So be careful because this function is f and the second function is g. So there's my f, there's my g. Now I'm differentiating f. If I differentiate f, I can see it's in the form of a chain rule. So how do I differentiate f? Because I've got a function raised to the power, so I need to apply the chain rule. So this is chain and product mixed. So if I differentiate the first function f, I'm going to get 6 5x minus 1 to the power 5, take away 1 from the power, and then differentiate the inside, I will get 5. That's only f prime. Leave the g, which is 3x plus 2 to the power 5. Add, differentiate g, I'm going to get 5, 3x plus 2 to the power 4, and differentiate g inside, which is 3, and then leave the first function, which is 5x minus 1 to the power 6. And we're supposed to simplify this because, see, this is f prime, and this is g, and this is g prime, and that is f. Okay, so I apply the rule. Now, how do I simplify? We can see we got 6 here, we got 6 and 5, that's 30. And we got 5 and 3, that is 15. So I can take out 15 as a common factor. And then from the brackets, I see I have 5x minus 1 to the power 5. And I have 5x minus 1 to the power 6. So I can take out 5x minus 1 to the power 5 as a common factor. Then I see I have 3x plus 2 to the power 5. So you do numbers first, then you move on to brackets. I've got 3x plus 2 to the power 5, and I've got 3x plus 2 to the power 4. I can only take out 3x plus 2 to the power 4. And now what am I left with? Take this piece over here, take the first term, and divide by the HCF, the highest common factor. So if I take the first term and divide by the highest common factor, 6 times 5 is 30, divided by 15 is 2. 5x minus 1 to the power 5, 5x minus 1 to the power 5 cancels out. 3x plus 2 to the power 5 divided by 3x plus 2 to the power 4 is just 3x plus 2. See how easy it becomes. Plus 5 times 3 is 15. 15 divided by 15, that cancels out. 3x plus 2 to the power 4, 3x plus 2 to the power 4 cancels out. 5x minus 1 to the power 6 divided by 5x minus 1 to the power 5 is just one of them. It's just 5x minus 1. Now you just simplify the second bracket and we're done. So I've got 15, 5x minus 1 to the power 5, 3x plus 2 to the power 4, and this is 2 times 3x is 6x plus 5x is 11x. 2 times 2 is 4, 4 minus 1 is 3. And that's my final answer. Are we good, guys? So what did I do
Yes.
here? I did chain and product mixed, product and chain rule mixed. Overall, the question is a product rule, but because of the way, because of the form of the function f, we have to apply the chain rule. So this is product plus chain, product plus chain rule. Okay, that's what it is. Next one, we are going to move on to the quotient rule. Fourth rule is the, yeah.
So we don't even need the quotient rule because we know the product rule. Oh, not the,
That's correct.
yes.
You can change the quotient rule into a product rule and then work with it, but I don't like working with it like that, because if I'm maximizing a function, a rational function, I'd rather just use the quotient rule because there's less algebra for me to do.
Mister,
Okay?
Oh.
Yeah.
well,
Yeah.
Ranja's question is very hard. I'm trying to solve it now.
No. Please don't solve those
Mister,
questions.
it's taking me
I will look at
one
it.
page and a half.
Look, I will look at that question at the end and we'll discuss it together, the topics and stuff that you need to know. So in order to solve that problem, just wait, I didn't even see it. I will look at it at the end of the session. Anyways, let's move on to the fourth problem, which is quotient rule. What is quotient rule? As the name suggests, it needs to be a rational function, right? So how do I do derivatives of rational function? If I have y equals f of x over g of x, so the derivative will become f prime g minus g prime f over, remember the product rule was 1 with a plus, but because this is a quotient rule, you're going to have over g squared. You have to square the denominator. Okay? So there, problem solved. Let's take an example from first principles. Remember the example that we did, the long example, and the fraction, we did a fraction example here. Yeah. So let's differentiate this function here. I'll just copy from here and move on to the next file because we are using rules of differentiation. So there's your general rule here, and let's apply it to this problem that I gave you in first principles. Without because we apply first principles if we don't know what the rule means. If we forget the rule, then we apply first principles. So let's say y prime is, there's your top function, which is the top function is always f and the bottom function is always g. If I differentiate the top function, I will get 3. Leave the bottom, subtract, differentiate the bottom function. We're doing g prime now. Differentiate the bottom is 5 and leave the top. All over denominator squared. That's it. 5x plus 2 all squared. Now we simplify the top function now. 3 times 5x is 15x plus 6 minus, someone had a question, yeah? 15x plus 6 minus 15x plus 5 divided by 5x plus 2 all squared. And we can see 15x minus 15x cancels out, and we got 11 over 5x plus 2 all squared. Did we end up with the same answer when we applied first principles? First principles mean we didn't know the rule and we were investigating it. So did we end up with the same answer when we did first principles? Yes, we did. 11 over 5x plus 2 all squared. Okay. Guys, do you all understand? Rizwan, Muhammad Tayyib, are we good?
Yep, makes sense.
Excellent.
Pretty easy.
Of course. Now let's do a mixture rule. I'm going to mix chain and quotient together. So I'm just going to raise these functions to powers, okay? So
Wait, mister, I have a
what?
question. Is
Yeah.
there like a, you know how like there's PEMDAS, so it's parentheses and exponents in that order like of priority. Is there like an order of priority for
Rules.
doing the rules, for having the rules? So is it like we do chain rule first and then we do the quotient rule, or is there like
No,
a
no, no.
way of doing that way?
There's a reason why you learn these 4 basic rules,
Mm.
because you need to know power rule, chain rule, product rule, quotient rule. These are the
Yes.
4 basic rules. The reason why we call it basic rules, because when we go on to other rules, like when we're differentiating uh,
We still
trigonometric
have
functions.
logarithmic functions as well.
Yeah, yeah. When we're doing derivatives of trigonometric functions, we need to apply quotient rule there. That's the reason why we learn. No, there's no
Okay.
order of this thing, because when you get an example, it's just going to be a mixture of all the functions, and you need to remember all the rules, and you look at the big function and then decide what to do.
Okay. Okay.
Yeah. We'll look at those examples later on. Let's learn the basic rules first. Right, so I'm going to give you another example with the, let's just say 5x minus 3 over the square root of x squared plus 1. Now, the top function is f, okay? The bottom function is g, but we can't go and differentiate square root of x squared plus 1. We need to put this in power form. So we're going to say 5x minus 3 over x squared plus 1 to the power half. Okay? Now we solve. We have y prime is equal to, if you differentiate, okay, let's make 5x minus 3 to the power 3. Okay? Because I said I'm doing chain and quotient mix. So it's quotient rule, quotient mixed toward chain, quotient plus chain, okay? Those are the 2 rules mixed, because we have functions raised to powers. So I'm going to differentiate f. So it's going to be 3 into 5x minus 3 to the power 2. Derivative of the inside is 5. Leave the bottom function, which is x squared plus 1 to the power half. Subtract. Differentiate the bottom function, half x squared plus 1 to the power negative half times the derivative of the inside, which is 2x, and leave the top function, 5x minus 3 to the power 3, all over the denominator squared. We're squaring the denominator, okay? Now, there's lots of cancellations happening here. Let's check what's cancelling. The first part, nothing's cancelling. The second part, we got half and 2x, so the 2 and the half cancels out. That's great. The denominator, the half and the 2 cancel out, just power 1, okay? So let's see. Let's rewrite this function, and now we can factor it out as well. Let's see. We got 3 times 5 for the numbers. Well, it doesn't factor out with anything, because we don't have numbers in the second part. Oh yes, guys, I forgot to write f prime g and stuff. So there's your f prime, right?
Sir,
There's your g function, yes.
is multivariable calculus in BC or no?
Multivariable calculus in BC, no. Single variable calculus.
Only single? Oh.
Yeah. G prime, and this is f. This entire thing is g prime, huh? And there's f. So we did f prime g minus g prime f over g squared. This is g squared in the denominator. All right. Now, we are trying to cancel out, we're trying to factor the HCF from the numerator only. Let's see the HCF on the numerator. Let's see. So we got 5x minus 3 all squared and 5x minus 3 all cubed. So we can take out 5x minus 3 squared. We got x squared plus 1. So between the 2 and the 3, how you know which one to take out? You take out the one with the lowest powers. Now next one, we got x squared plus 1 to the power half, and we got x squared plus 1 to the power negative half. So we have to go and take out x squared plus 1 to the power negative half, because that's a lower power between these two powers. Now we factor it out. Now the 5x squared minus 5x minus 3 squared and 5x minus 3 squared cancels out. 3 times 5 is 15, so we are left with 15 there. X squared plus 1 to the power half divided by x squared plus 1 to the power negative half is what? If you're dividing those two, what is it? So you got a to the power half divided by a to the power negative half. What's the answer? A to the power 1, because half plus half is 1. Do we understand that, guys?
Yes.
So I'm going to write over
Mister, but
here.
when you did the common factor, why did you take
Yeah.
it to the power of negative 1 over half? Why not positive 1 over
No,
half?
no. Well, because we take the lowest powers. When you're factoring 5x minus 3 to the power 2 and 5x minus 3 to the power 3, why did you take 5x minus 3 to the power 2?
Because,
Because between the
yes,
2 and the
yes,
3,
yes.
it's a lower
I
power.
remember now. You take the
Yes.
lowest power, yes.
The lowest power, yes. So now we are left with x squared plus 1 only. X squared plus 1 to the power 1. No need to write power 1. Subtract. Remember the half and the 2 cancel out, so we just left with the x there. X squared plus 1 to the power negative half and x squared plus 1 to the power negative half, those two cancel out. 5x minus 3 cubed divided by 5x minus 3 to the power 2. We are only left with one of this. 5x minus 3. All over the denominator squared, right? Denominator squared is just x squared plus 1. Now, next part. See this. These are like terms. You're taking this and you're dividing by this. So you're basically taking a to the power negative half and you're dividing it by a to the power 1. It's just basically 1 over a to the power. Take this negative half down. Becomes 1 over 1 plus half, which is 1 divided by a to the power 3 over 2. Are we good, guys? A to the
Yes.
power negative half divided by a to the power 1 is that. So in the denominator, I will have x squared plus 1 to the power 3 over 2. That's the problem with simplifying. If the question says do not simplify your answer, you leave your answer in this form. This is simplifying to find. Why do we simplify? Because when you do maximization problems and critical values, then we gotta simplify. So now we got 5x minus 3 squared. That part and that part becomes to the power 3 over 2, so that's out. Times, remember what's left in the second bracket. We got 15x squared minus 5x squared. 10x squared. We got plus 15 plus 3x. Okay, I wrote it in order. So 15x squared plus 5x, this is 15x squared minus 5x squared is 10x squared. I got plus 15 and multiply the negative x with the negative 3, I get plus 3x. That's my answer. Okay, right, guys? Do you understand?
Mm-hmm.
Right, excellent. So how many rules did we do? We did 4 rules. Next one, exponential rules. What is an exponential rule? We have y equals a to the power x, right? Or a to the power f of x. Let's make it general. So y prime becomes, copy this thing down, a to the power f of x times f prime x times ln a. That's it. All right, guys? Right, I'm not going to simplify because that's basic algebra. I'm just going to write the derivative for you. So I'm going to do 3 problems on this with the mixture rule. So I've got y is equal to 2 to the power x squared plus x. So what's y prime? Is 2 to the power x squared plus x times the derivative of the top, which is 2x plus 1. What derivative of x squared is 2x, and the derivative of x is 1, times ln 2. That's it. That's my answer. 5.2. Let's look at an example with the Euler's number. Y equals e to the power square root of x. For an example, what is y equals square root of x? Aha. Now when you're differentiating square root of x, we got a problem. Okay? So I'm going to write it out like this. So y prime is e to the power root x, but I still got to differentiate root x, right? So I'm going to say d dx of root x times ln e. And what is ln e? Ln e is 1. Okay? That cancel out. Ln e is 1. You can try it out on the calculator. Now, what is derivative of root x? d dx of root x. E to the power root x, d dx. Root x is x to the power half. So I will apply power rule here. Half x to the power negative half. Problem solved. Now take this negative half down and you get an answer e to the power root x times 2 root x. Remember, it's supposed to be times 1 over 2 root x. I just brought it down and put it like that. Yes. Question.
Mr. What rule of logarithmic functions is this?
This is not log function. This is exponential function. I didn't even come to logs.
Is it the one which is f of is it the rule where it's f prime of x equals e to the power of f of x?
No, I did the general rule. A can be anything, any positive number. Remember, A over here has to be positive. It's an exponential rule. Guys, did you understand this? I'm going to do one more example for Mesa here.
Mr. So the rule is f prime of x times a to the power of f of x times ln a?
Yeah, you copy the question down and then find the derivative of the top and take ln of the base. That's it.
No, repeat again. Mister, I don't understand. Do one more example.
You have a to the power f of x. You copy the same question down. The derivative is a to the power f of x. Take the derivative of the function f prime x and take ln of the base. The base is a. Okay, let's do one more example.
Mister, here, when you got 2 to the power of, go up just 1 second.
All right.
X squared plus x. So x squared plus x, so 2x plus 1 is the derivative of x squared plus x, right?
So first you have to bring down the question. You have to copy the question down.
Yes, I know. I'm saying.
And then multiply by everything else. Yes.
I'm saying 2x plus 1 is the derivative of x squared plus x, right?
That's correct, because that's what I said. Find the derivative of the power.
Okay. Yes.
Take ln of the base.
I understand now.
Let's take another one. Y equals, let's make a difficult one. 3 to the power 5x minus 1 over 2x plus 2. Okay? So how are we going to do this? This is the exponential rule, but when you're differentiating this, you're going to end up with a quotient rule. You get it? So we copy this question down. So Rizwan, this is the way you identify, okay? You identify the entire function, right? The entire function is exponential because it's 3 to the power, so it's exponential function. So this is exponential overall plus plus quotient, mixed with quotient. Right? Where's the quotient rule? The quotient rule is here now, multiplied by the derivative of the top. There's your f and g. The derivative of the top is, before I forget, let me write down len 3 at the end, and let me square the denominator. What's the derivative of the top? 5. Leave the bottom, 2x plus 1, minus derivative of the bottom. Differentiate the bottom. In other words, what's the slope of the bottom? This is a linear function. You shouldn't have a problem in finding the slope function. So the derivative of the bottom is 2. And leave the top,
Wait,
which
Mr.
is...
Sorry, is the denominator function 2x plus 2 or 2x plus 1?
Sorry, 2x plus 1.
Okay. Okay. 2x plus 1.
And leave the top. And that's my answer, right? Without simplification, this is my answer. The only thing that you need to simplify here now is this part over here, and it's quite simple. If you try to simplify that, you're going to get 10x minus 10x. That cancels out. Plus 5 plus 2. You're just going to get 7 on top. Right? And that's my answer. Are we good, guys? Mesa?
Yes.
Right, excellent. So how many rules we did? We did 5 rules.